Good day, everyone. It is another day of our discussion about science. I hope that you are ready in listening to our discussion about isotopes and average atomic mass. So let's begin. Not all atoms of an element are exactly the same, so remember that. For instance, this element carbon, or a carbon atom, in its most common form, which is carbon 12, and notice that it has 6 protons and 6 neutrons. The fact that it has 6 protons is what makes it an atom of carbon. However, there is what we call carbon 13, which has 6 protons and 7 neutrons. This number of neutrons can vary between the individual carbon atoms. So, therefore, from the usual carbon 12 and it has carbon 13 and carbon 14, we can say these variations are called isotopes. Isotopes are atoms of the same element that differ only in the number of neutrons. Here's one example of a carbon isotope. Carbon 13. Notice that while the number of protons in carbon 13 remains at 6, the number of neutrons has to increase from 6 to 7. This gives the carbon atom a slightly higher atomic mass than the carbon 12, but chemically, carbon 13 still behaves in the same manner as carbon 12. Another carbon isotope is carbon 14. Carbon 14 has a characteristic of 6 protons in all carbon atoms, but in this case, it has 8 neutrons. In some cases, isotopes may be unstable or radioactive. Radioactive atoms emit energy or subatomic particles in order to return to its stable state. This is the case of carbon 14. The radioactive carbon 14 has a number of applications in the field of science. Since carbon is found in all living organisms and the decay rate is well documented, we can use carbon 14 or carbon dating 14 as a way of dating how old is the sample of tissue that may be comparing its ratio of carbon 12 and carbon 14. Carbon dating 14 is used mostly in forensic studies and studying the archaeological remains like fossils. So, since we are done with the introduction of isotopes, let us now continue focusing on the calculation of average atomic mass. Average atomic mass is simply defined as the weighted average of the atomic masses of all naturally occurring isotopes of an element. So let us have problem number 1. Let us have boron. Boron is the only group 13 element that is nonmetal and has 2 isotopes, such as boron 10 and boron 11. If the abundance of boron 10 is 19% and the abundance of boron 11 is 81%, what is the average atomic mass of boron? So if we're going to solve for the average atomic mass, it is equivalent to mass multiplied by percentage, which is m1 times percentage 1 plus m2 multiplied by percentage 2. And if you have more masses and percentage, you can have m3 multiplied by p3 plus m4 multiplied by p4 and so on. So for our solution, you will just substitute the value of the mass 1 multiplied by the percentage 1, which is 10 multiplied by 0.19. Where do we get 0.19? It is from the 19% that must be converted into decimal point, plus the m2 and p2 multiplied by p2, which is 11 multiplied by 81% in decimal point, that is 0.81. So 10 multiplied by 0.19 is 1.9, plus 11 multiplied by 0.81 is 8.91. As you get the sum of the two, the average atomic mass of boron is 10.81. So take note of this, that the percentage must be always converted into decimal point. Now, sometimes you might get this problem or question in reverse. So let us have our problem number 2. Boron is the only group 13 element that is non-metal. Boron 10 and boron 11. That's the same question a while ago. But this is the one that is different from the question number 1. If the given average atomic mass of boron 10 and boron 11 is 10.81, what is the percentage of the two isotopes? So you are looking for the percentage. And if you are looking for the percentage, you still need to use the formula M1 multiplied by P1 plus M2 multiplied by P2. For our solution, since you have already the average atomic mass, you will just substitute 10.81 and then substitute the value of the mass, which is 10 multiplied by P1. Since you are looking for it, let us say P1 is X, plus M2, which is 11, and P2, which is 1 minus X. 10.81 is equivalent to 10X plus 11 minus 11X. So 10.81 is equivalent to, you need to combine like terms there, 10X plus negative 11X is equivalent to negative X plus 11. You need to subtract both sides by 11. So 11 minus 10.81 and negative X plus 11 minus 11. So you need to cancel there on the other side the same number 11. So you will have 0.19, negative 0.19 minus X. Since this is negative, you need to divide both sides by negative 1. So therefore, our answer for X is 0.19 multiplied by 8 by 100. So you can have 19% for boron 10. And to complete the 100%, 1 minus X is equal to 1 minus 0.19, equivalent to 0.81 multiplied by 100. So you will get 81% for boron 11. So if you add 19 and 81, you can have 100%. And this is the same with the percentage that was given a while ago for problem number 1. So it's easy, right? So you can review this problem number 1 and 2 in order for you to answer the activity that I will give for 1 minute. Now it's your turn to answer the activity. Problem number 3. While I'm reading this one, you can already solve for the average atomic mass. So let us have problem number 3. Rubidium is a soft silvery white metal that has two common isotopes, such as rubidium-85 and rubidium-87. If the abundance of rubidium-85 is 72.2% and the abundance of rubidium-87 is 27.8%, what is the average atomic mass of rubidium? So you only have 1 minute. You may start. So let's check. So still the same formula. We have mass 1 P1 plus mass 2 P2. For our solution, average atomic mass is equal to 85 multiplied by the P1, which is 72.2%. Convert it to decimal point, it will be 0.722, plus the mass 2 of 87 multiplied by the P2, which is 27.8. Converted to decimal point, it will be 0.278. So upon having the product of 85 multiplied by 0.722, this is 61.37. Then you add it from the product of 87 multiplied by 0.278, and that is 24.19. So you get the sum of the two. So the average atomic mass of rubidium is 85.56. Take note of this again, that the percentage must be converted into decimal point. You just need to divide it by 100. I hope you get the correct answer for problem number 3. Let us have problem number 4. Rubidium is a soft silvery white metal that has two common isotopes, rubidium-85 and rubidium-87. If the given average atomic mass of rubidium-85 and rubidium-87 is 85.56, what is the percentage of the two isotopes? Still the same formula, you will use M1 multiplied by P1 plus M2 multiplied by P2. So you only have 1 minute to answer this problem number 2. You may start. So let's check. For our solution, we have the average atomic mass of 85.56 equal to mass 1 or M1, 85, multiplied by the P1 represented by X plus 87 for the M2 multiplied by P2 represented by 1 minus X. So 85.56 is equal to 85X plus 87 minus 87x. So 85.56 minus negative 2x, we get it from 85x plus negative 87x. So this is negative 2x plus 87. Subtract both sides by 87. So you will have 87 minus 85.56 equal to negative 2x plus 87 minus 87. So you need to cancel the both 87 on the other side. And then upon solving, you can have negative 1.44 from 87 minus 85.56 equivalent to negative 2x. So we have negative 1.44 equivalent to negative 2x. You need to divide both sides by negative 2. Okay, so once you divide both sides by negative 2, your answer for x is 0.72, multiplied it by 100, so it will be 72% for rubidium-85. And therefore, to complete the 100%, we have 1 minus x, which is equivalent to 1 minus 0.72. So this is 0.28. Multiplied it by 100 to get the percentage. So it will be 28%. So that is for rubidium-11. So there you have it. You already know how to solve for the percentage and average atomic mass of an isotope of an element. Now, I just want to say thank you for listening. Thank you, everyone. Very good, guys, if you make it until this last set of problem. So thank you again for listening. See you on my next video. To keep you updated, you may subscribe to my YouTube channel, Mom PM is the Key, and click the bell button and select all. Thank you.